NENOMATICA, where mathematics meets YouTube excellence. The theorem states, if x is greater than y, then the floor of x is greater than or equal to the floor of y. It also states that if the floor of x is strictly greater than the floor of y, then x is greater than y. Today we will prove the first part. Step 1 uses the representation of a real number as the sum of its integer part and its fractional part. We state the floor function definition for both x and y. Now we start from the hypothesis. If x is greater than y, substitute both x and y with their floor plus fractional part, and keep in mind that both fractional parts lie between 0 and 1. Quick challenge. If x equals 2.7, what are the floor of x and the fractional part of x? Now for step 2, we compare integer parts using a key comparison rule. If a plus alpha is greater than b plus beta with alpha and beta in the interval from 0 to 1, then it must be at least b. Apply this directly to our substituted inequality. We conclude that the floor of x is greater than or equal to the floor of y. Intuitively, the fractional parts are too small to bridge a full integer gap if the floor of x were strictly less than the floor of y. Our final statement for this part is complete. The floor of x is greater than or equal to the floor of y whenever x is greater than y. Part 2. We now prove that if the floor of x is greater than the floor of y, then x is greater than y. We use two simple facts from the definition of the floor function. First, x is at least its floor. Second, y is less than its floor plus 1. Imagine the integers on a number line. If the floor of x is strictly greater than the floor of y, then the integer holding x is at least 1 more than the integer holding y. So bracket x is at least bracket y plus 1. Now chain the inequalities. Since x is at least its floor, and bracket x is at least bracket y plus 1, while y is less than bracket y plus 1, it follows that x is greater than y. This completes the proof. Let us summarize the key ideas we used and what to study next. As an intuition, think of x and y as bars made of an integer block and a small fractional cap. The integer blocks compare directly. The small caps, each less than 1 unit, cannot flip the order across an integer boundary. Great work following the structured algorithm. Keep practicing with more floor function theorems. In this lesson, we will prove an important property of the floor function. The theorem says the floor of n times x is greater than or equal to n times the floor of x. Here, n is a non-negative integer. Step 1. We use the basic decomposition x equals floor of x plus the fractional part of x. The fractional part, written as curly brace x, always lies between 0 inclusive and 1 exclusive. Here is a simple bar model to visualize this decomposition. The blue length is the integer part, and the orange length is the fractional part. Step 2. Multiply both sides by n. This gives nx equals n times floor of x plus n times the fractional part of x. Step 3. Apply the floor function to both sides. The floor of nx equals the floor of n times floor of x plus n times the fractional part of x. Step 4. Since n times floor of x is an integer, we can take it out of the floor. So floor of nx equals n times floor of x plus floor of n times the fractional part of x. Step 5. We already know the fractional part is between 0 and 1. Therefore, 0 is less than or equal to n times the fractional part is less than n. The floor of n times the fractional part must then be an integer from 0 up to n minus 1, which is always greater than or equal to 0. Step 6. From our result, floor of nx equals n floor of x plus floor of n times the fractional part. Since this extra term is at least 0, we conclude floor of nx is greater than or equal to n times floor of x. Let us verify with a quick example. Take x equals 2.7 and n equals 3. The left side is floor of 3 times 2.7, which is floor of 8.1 equal to 8. The right side is 3 times floor of 2.7, which is 3 times 2 equal to 6. Indeed, 8 is greater than or equal to 6. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.